everyone. In this lecture, we're going to be reviewing the Dmaic process improvement cycle. The Six Sigma system recommends a 5-step problem-solving methodology. And in this course, we're focusing on the process improvement strategy, which uses the sequence define, measure, analyze, improve, and control, abbreviated as Dmaic. And this 5-step roadmap is recommended for organizations that want to become a Six Sigma organization. In a company, Six Sigma projects must be identified, and those selected or prioritized according to the prevailing situation. Once a given project is selected, the Dmaic flow for that particular project begins. And in the first phase, the defined phase of the process improvement project, the project leader is responsible for understanding the target customer expectations. Now, customer often refers to the end customer, which is the one purchasing the product. But this customer can also refer to an internal customer. And the objective of this step is to establish standards for the products produced and the services provided based on inputs from the customer, so that the process performance can be judged and its capabilities predicted. So it's important not only to obtain the current customer needs, but also then to watch for the expected changes in these requirements over time. And we call this then listening to the voice of the customer, or VOC. The parameters which are then critical to quality, critical to achieve the customer needs or the voice of the customer, can then be identified, and the overall project goals can then be defined. In the Six Sigma teams, which I'll show on the next slide, comprises of top management, trained belts who have part or all of their work time allocated to the project. And in a full process improvement project, of the project team would be established to draw up a formal project charter, including setting up a project timeline, cost estimations, and finally, the team, in the end of the defined phase, should be able to gain a basic understanding of the process flow, start basic maps of the core processes, and see what data is already available. And this is, of course, all in preparation for the next step, which is measure. And just a word about the special organizational structure that the Six Sigma system calls for. It also requires continuous and rigorous cooperation among all the employees in the organization. The key players in a Six Sigma organization and their roles are listed here as follows. Executive leaders. These are highly visible, top-down commitment. They assume ownership of the Six Sigma process and create vision and goals. They identify opportunities, importantly, allocating resources and providing, you can call it inspired leadership. The project sponsor, sometimes called the champion, would be then the line manager or owner of the process who identifies and prioritizes project opportunities. The project sponsor would then select projects, also help provide resources, participate in the project execution, and help to remove barriers. Now, the Master Black Belt has an important role. This is someone who works full-time for Six Sigma implementation and has the responsibility for planning and providing technical support for the entire organization. The Master Black Belt will train Black Belts, act as a coach and a mentor, and provide overall leadership in the Six Sigma implementation. Black belts are people that are experts on Six Sigma tools. They work full-time on Six Sigma projects. They train the green belts, lead teams, and provide assistance with Six Sigma tools, for example, the different improvement methods, diagnostic tools, and statistical methods. Green belts tend to work part-time on projects with the black belts, and they integrate the Six Sigma methodology in their daily work and lead smaller projects. Yellow belts are employees who are trained in quality awareness and in Six Sigma basics and are part-time participants in a team. They contribute with process expertise. And finally, what's very important are financial representatives. These are people independent of the project team, but are very important to help determine the project costs and savings and report project benefits. Now, this course, this online course, the full online course, is targeting, my pen here, is targeting the green belt level. The training in the full professional certificate series are training people to be able to work at all levels at the green belt level, and for people that are interested in brushing up and preparing for a black belt test. We're offering a certificate from TUM at the yellow belt level because there's no project involved in this course, but the material that you're learning is at this green belt level. Now let's move on to the measure phase. Here we have these critical to quality outputs. These critical to quality parameters are identified from the defined phase, are defined, and here we want to measure them. We want to check the baseline process performance and see and evaluate it against the needs of the customer, the voice of the customer for the products and services created. At the end of this step, we want to be able to have a baseline evaluation of process performance and process capabilities, and this will be then known in a very quantifiable manner. The project team needs to understand the production processes in as much detail as possible, creating and measure a detailed process map. And this is then carefully reviewed in order to identify the inputs in the process which are likely to influence the critical to quality output parameters. A data collection plan will be developed and implemented for these parameters, and generally a measurement system analysis should be performed to make sure that the data we collect is correct. So for measure, we need to have a basic understanding of the statistics used for analyzing random variables. We need to know how to map a process and how to design a sampling plan and collect data. In the analyze step of a project, the project team analyzes the data for the key process parameters identified in measure, those which are likely to influence the critical to quality output parameters. In analyze, the object is to develop causal hypotheses and to establish the key influencing factors to improve the critical to quality characteristics by confirming or not confirming the effect of these parameters on the output. This phase can include development of cause and effect diagrams to identify potential causes, and here the statistical background for hypothesis testing, correlation, and regression are needed. In the improve phase of the Dmaic cycle, the priorities are established among opportunities for improvement, and the improvement projects, or the redesign projects, are completed and validated. Here we need to know how to design statistical experiments and to evaluate the significance of inputs on outputs. This will then allow us to evaluate the impact of a process change on our product or process quality. And in the final phase of the Dmaic process, we have the control phase. Here we ensure that the obtained gains are maintained for the long horizon. We use standardized documentation, employee training, and ongoing process monitoring with control charts, and statistical process control and control charts then are the key components for the control phase. So here we see the entire cycle one more time. In a Six Sigma company, defining Six Sigma projects, we start with define. We define the voice of the customer. We set up our teams. We move to measure, where we're looking for parameters. We're measuring our critical to quality parameters and identifying parameters that will influence these critical to quality parameters. Then in analyze, we're actually looking at the data to see if the effect of these influencing parameters on our outputs. Improve, we then look at different improvement projects to achieve our voice of the customer targets. And finally, in control, we want to maintain and continually monitor our processes into the future.